So the NASA DART mission, the results are in, and the news is good. It worked, and it worked better than they thought. So if you guys didn't know what the DART mission was, it's basically a mission that NASA had planned last year. Or at least they launched it last year. It was launched on a SpaceX rocket last year, and it finally made it to its target asteroid called Didymos and Dimorphos, because there's a binary asteroid system. So there's one large asteroid called Didymos, and then there's a smaller asteroid orbiting Didymos like a moon, and that is Dimorphos, and that's their actual target. So the goal of this mission was to see if they could just move an asteroid in space, and it's very simple and also pretty cheap too. Costs less than a brand new airliner. The whole mission. So the whole basically all they needed to do was crash a vending machine sized spacecraft or a satellite right into the orbiting asteroid. It's called Dimorphos, and the goal was to see if they could actually change its orbital period by just a small amount. They didn't want to have it fly away from its parent asteroid or anything like that. They just needed to see if they could slow it down by a measurable margin. So they were initially hoping to get it slowed down by like about 10 minutes, but they said the minimum, based on calculations, would be about 75 seconds. But they got way more than that. I mean, I'm sure there was a lot of people doing physics calculations and figuring this out, because obviously the laws of physics are applying here. If something exerts a force, then there has to be a reaction. But instead of getting a 10-minute delay on the orbital period of Dimorphos, they actually ended up with a They ended up with a 32-minute delay on the orbital period of Dimorphos. So that means that they slowed its orbit down by 32 minutes. That's how much of an impact they made. That's huge. That means that this is the first time humanity has ever moved mountains in space. At least they've moved mountains in space, because Dimorphos is about the size of, I would say, a Great Pyramid, in Egypt, or a skyscraper, or maybe a stadium. And out in space, obviously, it's weightless. So a vending machine traveling at 14,000 miles an hour, because that's the impact speed, it'll still carry a huge kick. It'll have a huge amount of force that it'll exert on that body in space. So it's like a bullet. I mean, a bullet travels at 2,000 miles an hour, and that's enough to go through you. This thing was a vending machine traveling at 14,000 miles an hour. So that is what, 7 times as fast as a bullet. So yeah, it left a huge amount of force on that orbiting asteroid, and yeah, they were able to move it. They moved it, and it created a huge mess too. The Hubble Space Telescope caught it. The James Webb Space Telescope was looking at it. It caught it. It caught what happened, and also there was a little CubeSat behind the main DART spacecraft that it kind of ejected out. So to actually just take a picture of the aftermath and what happened, and give us actually a photo of what it looks like to crash into an asteroid in space. That's really cool, actually. These CubeSats are really useful. They're useful for just filming the whole, the whole spectacle happening. They used the CubeSats in the Mars, I think was it Perseverance rover landing. And again, they've used these CubeSats, and they've come through. They sent back some pretty stunning photos. I'll show you, of the actual impact happening, and then all the dust and everything being ejected out all over the asteroid system. That's pretty big. So basically, this means that humanity won't have to worry too much about dying the way the dinosaurs died, by getting wiped out by an asteroid impact. Obviously, the dinosaurs were not smart enough to do anything about an asteroid, so they got hit and they got wiped out. But so humanity doesn't have to worry so much about these asteroid impacts. I think we probably have it covered at this point. The proof of concept has been proved now. It is possible to move these things out of the way, or deflect them out of the way, years in advance. They follow very predictable orbits. They can track it literally decades in advance. So there's no problem with dying from asteroids for human beings. But of course, there's probably lots of other ways we might go extinct. And the dinosaurs, they lasted, what, 200 million years, right? Or more than that. 200 million years because they weren't going to go around nuking each other, right? So, but yeah, there's lots of other ways that humanity will probably go extinct, and I don't think we're going to last 200 million years. I highly doubt that. So the dinosaurs still have us beat. They just got lucky that they didn't get hit for 200 million years. I don't know. Well, we'll see what happens. We'll see what happens. I'm not sure what'll happen, but we'll see what happens. But hey, at least we got that kind of checked off our list. If we can avoid nuclear war and viruses and other stuff like that, then we might make it. We'll see. But I think that's really interesting the way they were able to do that. And this is a relatively cheap mission and had an astounding success. Very interesting. They're able to move an entire asteroid like that. And they were able to do it with such precision. And that too, this thing was actually sending photos back as it was getting closer and closer and closer to its impact with Dimorphos. It was actually taking photos and sending it back one picture every second. And I was watching this. When all the pictures are coming back, it was getting closer and closer and closer, and the resolution was getting better and better and better as it got closer. And then it sent back one last partial image, right? It didn't send back an entire image. It sent back like a half an image. And that's because when it hit the rock, it was basically in the process of being disintegrated into a million pieces. So it still managed to get out like one half a photo of signal, and then it was obliterated beyond that. So that's why you only get half a photo. Yeah, that's another thing. I mean, this thing was literally taking photos till the very end. And yeah, we were able to get quite a lot of useful data from it. So 32 minutes, they've actually changed the orbit of a moon out there by 32 minutes. Humanity's pulled that off. I think that's really, really cool and interesting. And yeah, so that's it for this video. Like, share, subscribe, and leave comments below. I'll catch you guys in the next one. Salute.